just straight up memorization, right? You either memorized that little nugget of information or you didn't, right? So there's questions about organs and organ systems clearly. Most of y'all do okay. What organ system does the spleen belong to? Lymphatic, right? So I already put you in the ringer on that one. Sometimes, though, the questions can be more difficult, right? What organ system can you find in the left upper quadrant? And what's a possible correct answer there?
Digestive.
Lymphatic, because what? Yeah, spleen. But that's not the only organ system. So what if the lymphatic system isn't in your answer choices? Yeah, digestive, right? Digestive would be, for example, the
Liver.
Stomach, right? What'd you say? Pancreas. And what organ system is that? Okay, so I would know that. It's digestive, but it's also
Endocrine.
Right? So, harder questions on exam 1 typically present when I cross concepts, right? When I take one concept, organs and organ systems, and I mix it with another concept, in this case, quadrants of the abdominal pelvic cavity, right? The more concepts that interface in the same question, the harder that question becomes, right? Does that make sense? I gave an example of this already in the lab where I'm crossing concepts. So for example, I could say the visceral peritoneum is what to the parietal peritoneum?
It's
Inferior.
inferior.
Not inferior.
Deep?
Deep. Right? Inferior and superior, right? Well, yeah, I mean it is, but it's also not, right? Because you got the peritoneum all throughout. But the visceral is always going to be deep, right? Yes and no. Sometimes yes and sometimes no. The way I deal with that uncertainty on an exam is I don't even give you that option, right? I force you into the clear right and clear wrong answers, right? So your only answer choices would be deep and superficial. But if you've never thought about it before, all of a sudden now you're having to operate on the fly, applying knowledge rather than just regurgitating memorized bits. All right. So let's do another cross concept one.
You said the visceral peritoneum is deep to the what?
Visceral is always deep to the parietal. All right. So what is your patellar region to your digital region?
Distal.
Patellar is not distal,
No.
it's proximal.
Oh.
But what if I don't give you the option of proximal versus distal, right? What's your patellar to your digital if I don't give you proximal and distal? Superior, right? And that's another problem that you see with exam 1 in the lecture, is that you don't get the wide latitude of right answer choices. You get the answer choices that I have given you and not anything else.
Digits, that's fingers and toes?
Yeah.
Okay.
All right. So, in the general anatomy, we did organs, we did organ systems, we did cavities and quadrants, we did terms of relative position, we did body region terms, right? Peroneal, brachial, antecubital, right? That sort of thing. We did how to cut stuff up, right? All that's fair game. That's about a third of our test. Right? Anything about general anatomy that I can do specifically for y'all? Okay. And most of y'all feel pretty good about it. Sometimes I catch you a little off guard because it's sometimes more difficult than you expect it to be. So it is worth review. Right?
Are we going to have to know all the regional terms for the body, though?
Not all of them. You only have to know a couple of them that are on the exam.
Okay.
But since you don't know which couple are going to be on the exam,
Okay. So then, within like the terms of the body, are you going to ask like what this is, or are you just going to put that in a question?
both, right?
Okay.
Sometimes I will have a question that is just define this thing. which of the following terms refers to the back of the knee, right? And you'd have to say popliteal, right? But sometimes I merge it with another concept and I just use it when I write the question. And then either you know that word and can answer the question or you don't. What's up, Haley?
Are you gonna have written responses on the question, or is it gonna
It
be
is
all?
all multiple choice. Yeah, I get grumpy if I have a handwritten example.
Are there gonna be like pictures on there as far as like?
Sometimes yes, but it's not a major focus.
Okay.
Where I have pictures, if you saw a graph at some point, then there's likely to be a graph, right? So for example, we did this graph here. And sometimes this graph shows up, right? Yeah. So,
Homeostasis.
homeostasis, negative feedback, that sort of thing.
I mean, like for the chemistry part.
For the chemistry, you will have molecules written out. Okay, so let's do chemistry.
Oh, Lord.
Some of it's pretty straightforward, right? You got proteins that are that number, and you got neutrons that are that in number, right? And I say, what's the charge on that atom?
Positive.
You know, you don't know. You have no idea because I haven't told you how many electrons, right? What's the mass on that atom?
5.
5, right? Now I understand 3, right? So I would specify that you don't know in the answer and say this many protons, this many neutrons, you don't know how many electrons.
Are you gonna use a trick question?
Yeah,
Of course he is.
It will, again, I don't use the word trick, I use the word critical thinking. I can have that and ask you what's the mass, right? I don't know whether that counts as a trick question or not. What's the charge on that? We agree with -1, I think is what you said? Right.
Is it always protons minus electrons?
Always protons minus electrons.
Oh, that's how you put out the charge.
Yeah, the charge is always protons minus electrons. That equation should be somewhere in those PowerPoints. Mass is always protons plus neutrons.
That's what they do.
Right, so far so good?
So you said protons plus neutrons?
Protons plus neutrons is the mass. Protons minus electrons is the charge.
-1 is the charge.
-1 is the charge on that. I could, if I give you a periodic table, and I will give you a periodic table, I could say, what's the name of that atom? Do y'all know how to use a periodic table to figure out what atom that is? Right?
It's
So-
the top number, right?
Hmm?
The top number.
Yeah, protons tells you what the atom is.
And it's always protons minus the electron, right? So you can't be over this.
Charge is always protons minus electrons. Is that an ion? Yes or no?
Anion.
Say it.
Anion.
It's an anion, right? So that would go to my second question. Is that an ion? If it is it an anion or a cation?
It's an anion.
It's an anion because it's negative. I could point at that right there and I could say, how many valence electrons does that atom have? 2. It's got 2. Because we said that valence electrons are the number of electrons in the outermost shell. We said they always go from in to out. We said 2 in the first shell. So if we put 2 in the first shell, that leaves 2 left over. You are absolutely allowed to write all over your exam booklet, so you would just draw it out. You'd say, I've got my nucleus here, and then I've got my first 2 electrons, and so 4 minus 2, I got 2 left, and then my second shell, 2 electrons out of. I could,
There's a 4 total, but 2 on each shell.
yeah. Now how many, I could then, using just this information here, say how many more do you need to fill up the valence shell?
6.
6, right? So, but I wouldn't necessarily have drawn it. I would just say, how many electrons does it need to fill up its valence shell? And you would be expected to go through that process yourself.
So is the first shell just called shell 1 then, since the valence is the outermost?
Sure. Not a word for it that we're worried about. All right. So far, so good. All right. This is still the stuff. Right? Where are those particles located?
Nucleus.
Nucleus. What's the charge on each one of those?
Positive.
Yeah, positive one. I will at some point write for you a chemical reaction. Maybe a chemical reaction you have never seen before. Right? That's okay. So far, so good? Well, that's exciting. What type of bond is that right there?
Single.
Not just any kind of covalent, though. It's a polar covalent. Right? Remember that? O bound to anything that is not O, right, is polar covalent. How do we know it's covalent? Because it's a dash, right? How many electrons are being shared between that oxygen and that hydrogen in that bond? 2 electrons. How many pairs of electrons are being shared? 1 pair, 2 electrons. You have to read these questions with a fine-tooth comb. One word in a question is the difference between getting it right and getting it wrong.
Okay, how you know two electrons?
Pair is always 2, right? Each dash is a pair.
Is a pair. That's
Yeah.
So where did the 3 come from?
Yeah.
Doesn't matter.
Oh,
Right?
okay, so you're gonna have it written out like that, we didn't have to solve it and make it that, so.
See where it came from?
Mm-hmm.
Okay. But that doesn't matter because we're not doing that. That's a much more difficult chemistry class.
Why would you not put the
You're
fourth?
just
Well,
You're just
wouldn't
reading
H1
it.
have 2 then?
Hmm?
Wouldn't H1 have 2 then, and then more just
Doesn't matter.
Why would you not put the fourth hydrogen on?
Hmm?
Why would you not put the fourth hydrogen on?
I've got all 4.
I mean, like, whenever you, why is it H3 and not H4?
Maybe because the other H is
Because
on
my
the
other
other
H is
side.
over here.
Or like, why does it go over there and not with the rest of them?
Why? That's a difficult question to ask here in science. The why is because of various affinities for electrons and hydrogen atoms and what is the most stable configuration given the various atomic orbitals. I mean, do you really want me to go into that answer right now?
No.
No, of course not. Of course not. So you don't have to know any of that. You just gotta look at it and you just gotta interpret it. So I could point at one of those bonds and say, is it covalent? Is it polar covalent? Is it 2 electrons? Right? So I could say, based on this thing here, is that likely to be a partial positive or a partial negative? Partial positive. Because we said the oxygen is always the partial negative. And anything opposite is always the partial positive. What was your question?
So why is it negative over there on the left?
Who cares? All you gotta do is read it and say negative. Right? I mean, I can count the number of protons and electrons here and do the math. I actually did it in the acid-base stuff. Right? That's a hydroxide, right? So we talk about hydroxide, but it doesn't matter for this question. I would just point at that and say, that's a cation. True or false?
Negative.
False.
False, right? Because cations are positive and that one is clearly negative. Or I point at this and say, how many hydrogen atoms are there in this molecule?
3.
3. How many oxygen atoms are in this molecule?
1.
How many of this molecule are produced?
1.
Is this a reactant or a product?
Reactant.
Right? Everybody see. My goal here is not understanding why a chemical reaction occurs the way it does. My goal here is for you to look at a chemical reaction that I am telling you occurs and and then you'd be able to read it.
The numbers that go with kind of like the age, what are those numbers stand for again?
The one that's on front is how many molecules.
Yeah, how many molecules?
Okay.
Yeah, so, I mean, I could have put a 1 here, but the convention is to not put 1. So let's do another.
Oxygen is partial negative and partial positive or whatever.
Oh, yeah.
Why it is? I have no idea.
Right? Totally different chemical reaction. I haven't shown you any covalent bonds, so I don't expect you to know what's a covalent bond and not. I'm not gonna ask about it. But in answer to your question, I'll be right with both of y'all in just a second. To answer your question, there's that number.
Okay.
So this is the molecule. That tells you how many molecules.
Okay. And the other one is how many atoms?
That is how many atoms.
So this is the one that's both the product and reacting, right?
It is now, but it wasn't before.
Okay, so what makes it both the
If your
product?
arrow points both ways, then both sides are products and both sides are reactants.
What happened to the little one?
If your arrow points one way but not the other, then what it points to is products. What it points away from is reactants. But that changes simply by reversing that arrow.
Okay.
Did you have a question, Ivy?
Why is oxygen partial positive or partial negative? Like, what was the last thing?
So we said oxygen bound to anything else, right, is a polar covalent bond. Anytime you have a polar covalent bond, one side is a partial positive, one side is partial
Oh,
negative.
because it was.
Oxygen always likes the electrons, and so it is always the partial negative in a polar covalent bond.
Okay.
Can you just not?
So then, you said the 2 is the molecule and the little 2 is the atom? Yeah.
So this is number of molecules. This is walked through on the slides for what it's worth. That is number of atoms.
Okay, so then would that mean you have technically 4 atoms because there's 2 molecules?
Yep, there are 4 hydrogens total in these 2 molecules.
Okay. What happened to the 2 atoms in the oxygen on the inside?
It makes 2 water molecules.
Right. So I've got 4 H's total.
Okay.
I've got 2 O's total. So my number should balance out on either side. Just rearrange that.
Right, just think of the water molecule, how you have the circle of
Oh, the
oxygen
2
and
is
the
the
2
ball.
hydrogen.
Alright, let's do another one.
Oh, I understand.
Let's do another one. 11. So,
Chemistry probably.
yeah, that's pretty exciting. That is one of our 4 classes of macromolecules. What is it? Well, I heard something to do with saturated and unsaturated. So what's the class of molecules though? Is that a carbohydrate, a nucleic acid, a protein, or a lipid?
Lipid.
What type of lipid is it?
Phospholipid.
Yeah, not a
No.
phospholipid.
I don't know
It
then.
is a fatty acid. I mean, it's a really short chain fatty acid, but that's same basic structure.
Fatty acid. Not a phospholipid.
I
I
don't
don't.
know, you tell me.
I
Is it
will never get
unsaturated or
this.
saturated? How do you know? Yeah, that carbon-carbon double bond there, that makes it unsaturated. How many total electrons are being shared in this double covalent bond? 4 electrons. This region here, is that hydrophobic or hydrophilic? Hydrophobic. Anything that's got just hydrogen and carbon is hydrophobic. This region here, is it polar or non-polar?
Polar.
Because it's got oxygen. Anything that's got oxygen is polar. That molecule is amphipathic. True or false?
True,
Why?
because it's got hydrophobic and hydrophilic.
Perfect. Right? If you are both hydrophobic and hydrophilic simultaneously on different ends, you are amphipathic. So far, so good? Easy.
So
It's terrible. I mean, it's terrible. But it's the part that you're worried about, and if you give you enough time to study it, it's the part that you will study the most and actually do the best on. Right? What's up, Red?
So with two shared electrons, the two pairs.
Two pairs.
That means it's saturated?
No, anytime you have this hydrocarbon tail, if that hydrocarbon tail possesses a carbon-carbon double bond, it is considered an unsaturated fatty acid. That is a saturated fatty acid. Saturated with hydrogen. I have added as many hydrogens as I can possibly add. All right.
How did you know it was a fatty acid to begin with? Like how would
So fatty acid has a hydrocarbon tail. So there's a long string of carbons with hydrogens on it. And that carboxylic acid, that OCOH. So if you see this on one side, and you see a string of carbons and hydrogens on the other, fatty acid. Sometimes this string is very long, particularly if I really want to emphasize that it's a fatty acid.
And it's specifically the
OCOH is a carboxylic acid. No, I mean you see it in other places too. But I'm not gonna do it. If I want the answer to be fatty acid, it'll be OCOH on one end, it'll be over here instead. Do you have a question with that? Okay. So this is another third of our test. Okay, all the way from protons, neutrons, electrons, all the way up to this one here. Okay. So guys should typically do okay on this stuff.
I think this is just
as long as you do
general.
my last third of the test. Okay. A large chunk of it is on movement of molecules.
Oh, God.
And I'm not kidding about that osmosis diffusion stuff being overrepresented, right? You're going to have a hard time getting a B if you can't answer those osmosis diffusion questions. Right? So some of the questions, it's just that container. You line it up, a lot on one side and just a little bit on the other. During diffusion, what direction is the solid going to move? You know, that's never the answer.
Oh, from B to
B to A, right? Assuming that those dots are the solid. In osmosis, what direction is the solvent going to flow? A to B, right? So if you can do that, that's a clean 4 points, right? Sometimes I ask you about the name of the process. So if the solute is moving, what's it called?
osmosis?
Nope. Diffusion, right? Osmosis is the solvent. If the water moves, what's it called? Osmosis, right? So this thing here allows some things to cross but not others. So what's our term for that thing there?
Not permeable.
Semi-permeable, right? In a shell, the semi-permeable membrane is called what?
Some membrane.
Yeah, it could be cell membrane or plasma membrane. Right? Sometimes I am real Richard on these questions, though. Right? Which of the following structures has a semi-permeable membrane? The cell, the nucleus, The endoplasmic reticulum, the mitochondria. That's true.
Nucleus.
all
Oh.
Because we said true membrane, or true organelles, have their own membrane. And so each one of those things that I named that wasn't the cell itself was a true organelle. Meaning every one of them had a membrane. Meaning every one of them had a phospholipid bilayer. Meaning every one of them had a semi-permeable membrane. Right? Does that make sense? So, you have to apply the information. You have some ability to predict some of these questions, right? You know there's going to be a question that says, is this thing a reactant or a product? But I have ways to engineer these questions that allow me to tell the difference between I memorized stuff on slide 37 and I understood what it said on slide 37 enough to apply that information to a novel circumstance, right? Memorization gets you a C, for sure, right? You want an A, you gotta apply the information. That's that trick question. So let's do something. So you have a cell. You have suspended that cell in a beaker with a solution. You observe that there is a movement of water from inside